In units K and L, we are starting to talk a little bit more about the coordinate plane, and we have to start with the basics, and so we're looking at the midpoint formula and distance formula. And in order to come up with those formulas, let's consider in problem 1, I have segment FG, and its endpoints are at -3 and 7, and we're asked to find the coordinate of its midpoint. Remember, a midpoint is a point that divides a segment into two congruent segments. So I want the point that is in the middle of two other points. And if you think about this numerically, then the number that's in the middle of two other numbers, I'd hope that you'd remember, is the average of the two numbers. So if I take this -3 at F and this 7 at G, and I average them together, let's look at the number that we get. -3 plus 7 is 4. 4 divided by 2 is 2. If I take that point and plot it on this same number line, notice that that 2, let's call it M, is 5 spaces away from F, and it's 5 spaces away from G. So M is, in fact, the midpoint of segment FG. And I found that simply by finding the average of those coordinates. So if the coordinates are A and B, midpoint of that segment would be A plus B divided by 2. And if I take that into the coordinate plane, what I'm basically doing is finding the average of the x's and the average of the y's. And what that looks like in a formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And in the next problem, we're simply using that formula in order to find the midpoint. So, midpoint of segment xy, let's call it M, is the average of the x's comma, the average of the y's. And then we clean that up. 5 plus -2 here is 3, and 3 over 2 is just 1.5. And then 5 plus 12 is 17. 17 divided by 2 is 8.5. So this is our answer. And the main thing that I would want to stress to you when you're finding the midpoint in the coordinate plane is that you're finding a point. And a point in the coordinate plane has two coordinates. So make sure that your answer has two numbers in it. Pause a moment to find the midpoint. This problem is a little bit different. They've already found the midpoint. It's located at A, 2, -1. The problem is we don't know one of our endpoints. We know one of them, it's -3, -5, but we need to find the other one. The book shows you a method that uses algebra. The book says x1 plus x2 over 2 is going to equal the x-coordinate of your midpoint. And y1 plus y2 over 2 is going to equal the y-coordinate of your midpoint. And then we know one of our x-coordinates, it's -3. Oh goodness, that was way too big. So I would take that negative 3 and plug in for x sub 1. So I'd have negative 3 plus x sub 2 over 2 equals 2. And I know that the y-coordinate of one of my endpoints is negative 5. So I know negative 5 plus y sub 2 over 2 equals negative 1. And then I solve for my two variables. So I multiply both sides by 2 in this equation. I get negative 3 plus x sub 2 equals 4. And when I add 3 to both sides, x sub 2 is 7. Same idea here. I multiply both sides by 2. I get negative 5 plus y sub 2 equals negative 2. I add 5 to both sides, and y sub 2 is 3. So the answer is 7, comma 3. So even though we've found the answer, I would like to show you another way that you can approach this problem that I think some of you will probably prefer. So here we go. I take this segment, so they've already drawn this for me, and I put the coordinates in their appropriate places. So this is negative 3, negative 5, and my midpoint is to negative 1, so that's here. And then I use what I noticed in the beginning of this lesson. I used the fact that the midpoint in problem 1 was as many spaces away from F as it was from G. So the way that I'm using that is to figure out how far away the x-coordinates are and how far away the y-coordinates are. And here's what I mean by that. From the negative 3 of this x-coordinate to the positive 2 of this x-coordinate, I would have to add 5. And so if I just add 5 again, I'll end up with my new x-coordinate, which is 2 plus 5 is 7. And then I do the same thing with the y-coordinate. From negative 5 to negative 1, I would have to add 4. So if I just add 4 again, I'd have negative 1 plus 4, giving me 3, which is the exact same answer, but I got the other way. But myself personally, I think that took up a lot less time and energy. So use whatever method works best for you. And use it in this your turn. So let's think about how we would find the distance between 2 points. So let's say I have a point here and a point here. And I'm not even really focusing on what those numbers are at this point. What I'd like you to consider is, even though I don't have a formula yet for how to find the distance between those 2 points, I could draw this vertical segment here, and I could draw this horizontal segment here. And I could very easily find the length of those segments by just counting the spaces. Okay? So in this particular instance, when I count those spaces, it's 8. And for my red segment, when I count those spaces, it's, oh, look at that. It's also 8. That was purely by accident. Well, okay, So I can find the vertical segment and that horizontal segment, but I still haven't found the distance between the 2 points that I started with. Then how about if I draw this segment? What I'd hope that you'd realize is that the distance between those 2 points is the hypotenuse of this right triangle. And in a right triangle, when I know 2 sides, I can easily find the third side using Pythagorean Theorem. Okay? So what happens when I have generic points like x1, y1 and x2, y2? Well, if this is x1, y1, and this is x2, y2, then the length of this segment is just the difference between the x's. So that's x2 minus x1. The same idea applies with this segment. It's the distance between my y coordinates. And if I put that all together into Pythagorean's theorem, I end up with x2 minus x1 squared plus y2 minus y1 squared equals d squared. And as far as coming up with a nice, well, I wouldn't call it neat formula, it's kind of messy, but it is just a formula. The distance between those 2 points is just the square root of all this stuff. And so this is the means by which we can find the distance between 2 points in the coordinate plane. If you really wanted to, you could plot the points, make the right triangle, and use Pythagorean's theorem, and you'll end up with the same answer in the end. You're just adding the work of plotting the points in the coordinate plane when you really don't have to. Okay, so here's my formula. Copy and paste that. So I can use it to find the distance between these 2 points in problem 3. Some students might find it helpful to label x1, y1, x2, y2. So x1, y1, x2, y2. And then we're just plugging the values into the formula. So square root of negative 5 minus 6 squared plus 3 minus, be really careful with your signs, negative 2 squared. And then you're just cleaning things up. This is negative 11 squared plus 5 squared. When you square a negative number, realize what you're doing. You're taking a negative times a negative, which I hope you to remember is a positive. So you have the square root of 121 plus 25, square root of 146, and the instructions said round to the nearest tenth. So in your calculator, you take the square root of that and get 12.1. Take a moment to work through the your turn.